Welcome to EDU World Space.
This question asks us to determine the coordination number and oxidation number for the metals in each complex. So we're going to start with the first one, which is A. So we have Na2CdCl4. Now the coordination number is the number of ligands attached to the metal within the complex. So for this compound, the oxidation number, the coordination number, which I'm going to put core, is 4 because we have 4 chlorines attached to this metal. Now the oxidation number is going to be the charge of this metal in this entire complex. So in order to do that, we need to calculate the charge of each component in the complex, where we know that Cl4 is going to have an overall charge of -4. I'm just going to write that above so we can keep track of it, -4. Because chlorine overall is a -1, and there are 4 of them. Sodium is going to have a +2 because sodium innately has a +1, and there's 2 of them. That's +2. And then by that, we know, because this whole molecule is neutral, they didn't give us any charge at the end, that this metal needs to be a +2 because it will need that +2 to balance out this whole charge. So we have our oxidation +2. We can do that for each of the complexes, where we have this K2MOOCl. Our coordination number is going to be 5 because we have, oops, sorry, I wrote this wrong. This is Cl4. We have 5 things attached to this molecule. Our oxidation number, again, I'm going to write above with the charges of each molecule. We'll start over here. Our potassium is a +1 charge. There's 2 of them, so that's a +2. Our oxygen is going to have a -2. And then chlorine again has a -1 charge. There's 4 of them, so it's a -4. So we know that this metal needs to be a +4. This part C, this complex CONH3,4Cl2Cl, our coordination number, we're going to have 6 things attached to this cobalt. And with the oxidation number, we're going to go from back to front. So chlorine is a -1. Again, Cl, there's 2 of them. It's a -2. Our NH3 is neutral, so even though there's 4 of them, it's just going to be a 0 charge. That means that our cobalt needs to be +3. Continuing on, go to this next page. We have this nickel complex where our coordination number is going to be 5 because we have 5 CNs attached to our nickel. Core again, coordination number. And then our oxidation number, Cn is a -1 by itself, so this overall is a -5. We know the overall charge is a 3-, so we know that the nickel has an oxidation state of +2. Part E, this potassium, or K3VC2043, our coordination number is going to be 6 because we have 3 of this bidentate ligand, and so there are going to be 6 things attached to this metal. That's 6. And then our oxidation number, this complex itself is a -2, and there's 3 of them, so this is going to provide a -6 charge. Potassium is +1, there's 3 of them, it's going to be a +3. and there's no charge on this molecule, so we know that our oxidation state is going to be +3. Finally, this last complex, we've got ZN EN2, which this is just a code for bidentate ligand, BR2. So because there are two of these, this bidentate ligand, our coordination number is going to be 4, and our oxidation state, we can determine Br is a -1, and there's 2 of them, so we're going to be -2. En is a neutral molecule, so it's going to be 0, which means that the oxidation number for this metal needs to be +2.